Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here, and in this video, we are going to be looking at how to use a bivariate scatter plot. So by the end of this lesson, you'll be able to do these three things: determine the form, direction, and strength of an association, identify independent and dependent variables, and describe bivariate data sets. Okay, so just to reiterate, bivariate, bi means two, variate means variable, so we're comparing two variables to see whether there's a relationship or not. So let's have a look at the first one. Determining the form, direction, and strength of an association. So an association is just another word for relationship or correlation. Okay, so they all mean the same thing. So if you see the word association, think, is there a relationship between the two variables, between the independent variable and the dependent variable, okay, between the x and y values. So if a scatter plot looks random, like it does here on the right, and there doesn't seem to be a pattern or a trend, then we say that there is no association or no correlation or no relationship between the two variables. Okay. However, if there is an association, we can determine its form, direction, and strength. So let's have a look at the first one, form. It could be in a linear form if it seems to form a straight line. Okay, because remember, linear means straight line. So when we did linear relationships, they were all straight lines. Okay, a non-linear form means not straight lines, right? So it's a curve. So here we've got a curve. If we had another one that looked maybe like this, okay, that would be a curve as well. That would be non-linear, or maybe we might have something like this. Okay, also non-linear because it forms a curve. So linear, non-linear, straight line, not a straight line, a curve. Alright, what about direction? We can have positive or negative. So positive association exists between the variables if the gradient of the line is positive. That means it's going up from left to right. Okay, so here it's going up from left to right. So it's positive. And if it's going down from left to right, it's negative. Okay, pretty self-explanatory. So let me just explain what that means, right? What that means is, as x increases, so for this one, for positive, as x increases, y also increases. So maybe as your height increases, your weight will increase as well. Okay, so that could be, so maybe height and weight could be an example. Whereas for the negative one, as x increases, y decreases. So maybe, for example, as the noise level, as noise level increases, your ability to study decreases. Okay, so they will have a negative association. Alright, let's have a look at strength. So if all the dots are very close together, so if we can form a straight line, okay, we were to draw a straight line and the dots are very close to that line, of best fit, if you want to call, then we say there's a strong association. There's a very strong relationship between the x value and the y value, or the two variables. However, if we were to draw a line of best fit and they're a little bit more spread apart, they're not as clustered together, then we say there's a moderate relationship. But if they're even further spread apart, but we can still see that there's a relationship, a correlation, or an association between the two variables, then we say that there's a weak association. Okay? Right, so now we know how to determine the form, the direction, and the strength. Let's have a look at how to identify independent and dependent variables. So I guess a quick intro to this one is whenever we graph or whenever we do a table of values like x and y, x is always at the top, y is always at the bottom. And when we graph it, x is always here and y is always on the vertical axis. So x is the horizontal axis, y is the vertical axis. Which means that x is always the independent variable and y is the dependent, if I can write that. So x is independent, y is dependent. What that means is the value of y depends on what x is. That's why when we put in, for example, y is equal to 2x plus 1. If x was 0, then this would become 2 times 0 plus 1, which is 1. That y depends on what x is. Because x is 0, y is 1. If x was 1, that would be 2 times 1, which is 2 plus 1, which is 3. Okay, the value of y depends on what x is. Because x is 1, y is 3. And so when we have a look at this question here, the table below shows the time taken in hours relative to the distance traveled in kilometers. Here, we just need to assume or pretend that this distance here, because that's at the top, that's an x. And this time here, that's a y. Okay, so I might answer question B first rather than question A. Question B says, which are the independent and dependent variables? Well, because x is always independent, distance here is independent, and therefore time is dependent. In other words, the time it takes depends on how far you traveled. Okay? Alright, so now we know that distance is the independent variable and time is the dependent variable. We can actually graph our scatter plot, and I'm just going to change my lines to this. Okay. So that means we have distance on the x-axis and we have time on the y-axis, and this is in kilometers and hours. So kilometers and hours. So what I want to do now is I want to have a look at my table of values. Okay, my distance is going from 0 to 50. So I might go from 0 to 50. I'll probably go up by tens. 10, 20, 30, 40, and 50. And for my hours, I'm going from 0 to 1. I might go up by 0.1. So we got 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0. Okay, so now that we've done our axes, let's draw the scatter plot. So the first one is 0, 0. So I'll just do this in orange. Now we can do this as dots or we can do this as crosses. Let's do it as crosses, because that's what I'm used to. Okay. 10, 0.25. 10, 0.25 is about here. 20, 0.38 is about there. 30, 0.59, about there. 40.82, about here, and 51 right there. And that's it. Okay, do not join the dots, do not join the crosses, do not draw a straight line. Okay, here it just asks us to draw a scatter plot, and that's it. If the question asks us to draw a line of best fit, then we would do that, but now we don't need to. Okay? Alright, let's move on to the last thing. Back to this. Alright, so last thing for this lesson is describing bivariate data sets. Now that we know how to determine the form, direction, and strength of scatter plots, let's try and apply that to an actual data set. So the table below shows the height, centimeters, and weight in kilograms of 9 people. Question A asks us to construct a scatter plot using the above table. So I'm going to go back to, let's just go back to this. We've got height, where we normally draw our table values. X goes at the top, Y goes at the bottom. Therefore, height is at the bottom. Okay, height is on the x-axis. Height, that's in centimeters. Weight, and that's in kilograms. And that's the y-axis. Okay. Our height goes from 163 to 190. So I might start at 160 and go up by 5s. Okay, so 160, 165, 170, 175, 180, 185, and 190. And our mass goes from 55 to 78. So I might start at 55, go up to 80, and go up by 5s. So 55, 60, 65, 70, 75, 80, 85. Alright, so now we've got everything we need. Let's draw our scatter plot. 55, 163. That is about here. You've got 165, 60. 165, 60 is here. 170, 64. Alright, I'm going to get you to pause the video, continue with this yourselves. Okay, so this is the answer to the scatter plot. Yours should look around the same. Let's have a look at questions B, C, D, E, and F now. So question B says, describe the form. To me, it looks like it's a straight line. It doesn't look like it's a curve at all. So I'm going to say it's linear. The direction, well, it's going up from left to right. Therefore, it's positive. The strength, well, if I were to draw a straight line, they look pretty close. Okay, the crosses look pretty close to that, so I'm going to say it's strong. And now we're going to predict the mass of a person who is 173 centimeters tall using the scatter plot. So 173 is about here, which means how heavy are they? It looks like they're about 64 kilos. Alright, we're going to predict the height of a person who has a mass of 75 kilograms. So 75 kilograms. It looks like they are about 187.5 centimeters tall. Now, your answers will differ depending on how you drew your line of best fit. So if your line of best fit, it looks a little bit different to mine. Your answers here will be different. Now, In a test, we're not going to mark it wrong as long as your line of best fit looks reasonable. If your line of best fit looks completely out of whack, then you will lose your marks. Okay, so don't worry if your answers here are different to mine. Alright, that's it for this video.